Hello friends, welcome to my YouTube channel, Raja Gogasikotar 1719. For centuries, humanity has looked up at the moon, our nearest celestial neighbor, wondering what secrets it holds. Is it a barren rock or something more? What if I told you there is water on the moon, and it might rewrite everything we thought we knew about our cosmic companion? Today, we're diving deep into a mystery that has puzzled scientists for decades. Where did the water on the moon come from? Get ready for a journey through space, time, impacts, ice, and ancient chemistry. This is moon water. 1. The moon we thought we knew. For thousands of years, the moon has watched us. Ancient civilizations worshipped it. Poets wrote about it. Scientists studied it. But one belief remained unshaken for generations. The moon was completely dry. A lifeless, airless desert of gray dust and silent craters. When astronauts from the historic Apollo program landed on the lunar surface between 1969 and 1972, they brought back over 380 kilograms of rocks and soil. The world waited. Scientists carefully analyzed every grain, and the conclusion seemed clear. No rivers, no lakes, no moisture, no water. The moon, they said, was bone dry. This belief wasn't just an assumption. It made sense. The moon has no thick atmosphere, no weather, no protection from the sun's harsh radiation. During lunar day, temperatures rise above 100 degrees Celsius. At night, they drop below minus 170 degrees Celsius. In such extreme conditions, water shouldn't survive. If any existed, it should have evaporated into space billions of years ago. So for decades, textbooks confidently declared, the moon is a dry world. But science is a story that keeps rewriting itself, because sometimes what we think we know is only the beginning of the mystery. And soon, a discovery would shake that belief to its core. The dry moon was about to become wet with possibility. 2. The discovery that shocked the world. For nearly 3 decades after the Apollo missions, the case seemed closed. The moon was dry, but in science, the truth often hides in the details. In the 1990s, something unexpected happened. New orbiting spacecraft began scanning the lunar surface with more advanced instruments than ever before. Instead of just looking at rocks, they studied the chemistry of the soil, searching for hidden elements. And then, they found hydrogen. Hydrogen is one of the key ingredients of water. At first, scientists were cautious. Was it contamination, instrument error, or something far more extraordinary? The mystery deepened in 2008 when India launched Chandrayaan 1. This mission carried a powerful instrument designed to analyze reflected sunlight from the moon's surface. What it detected stunned researchers around the globe. Spectral signatures, tiny but unmistakable signs of water molecules spread across the lunar soil. Not oceans, not lakes, but traces, scattered like invisible fingerprints across the moon. Then came the moment that changed everything. In 2009, NASA launched LCROSS, the Lunar Crater Observation and Sensing Satellite. Instead of landing gently, it crashed. Scientists deliberately sent the rocket stage slamming into a permanently shadowed crater near the moon's south pole. The impact created a massive plume of debris that rose high above the surface. And when scientists analyzed that plume, they found it. Water. Not just molecules attached to dust, but actual water ice mixed within the lunar soil. The dry moon was no longer dry. The scientific community was stunned. For decades, we believed the moon was a dead, dehydrated world. Now, we knew something incredible. Water had been hiding in the darkness all along. And this discovery didn't just rewrite textbooks. It changed the future of space exploration forever. Because if there is water on the moon, then the moon is no longer just a destination. It becomes a stepping stone to the stars. 3. Hidden in eternal darkness. So now we know something extraordinary. There is water on the moon. But a new question rises. Where could it possibly survive? The moon has no thick atmosphere, no protective magnetic shield like Earth. Under direct sunlight, the lunar surface becomes brutally hot enough to boil away water into space. So how can ice exist in such a hostile world? The answer lies in shadow. Near the moon's north and south poles, there are craters so deep, so steep, that sunlight has never reached their floors. Not for days, not for centuries, not for billions of years. These regions are known as permanently shadowed regions. Inside them, temperatures drop below -250 degrees Celsius. Colder than Pluto, colder than most places in the solar system. In these frozen pockets of darkness, water molecules that would normally escape into space become trapped, like time capsules, preserved, untouched. Scientists believe that when water arrives, whether from comet impacts, asteroid collisions, or chemical reactions, some of it migrates across the surface. Most of it disappears, but a fraction finds its way into these eternal shadows. And once it falls in, it never leaves. Imagine craters that have not seen sunlight since before complex life existed on Earth. Imagine ice that has been frozen there since the age of dinosaurs, or even before. These shadowed craters are not just cold traps. They are archives of cosmic history. And at the heart of this frozen darkness lies the key to humanity's future in space. Because if we can reach that ice, if we can extract it, then the moon transforms from a lifeless rock into a gateway to Mars and beyond. But this raises an even deeper mystery. How did the water get there in the first place? Was it delivered, created, or born with the moon itself? In the next chapter, we explore the powerful forces that may have brought water to our nearest neighbor. 4. The origins of lunar water. We now know the moon holds water, hidden in darkness, frozen for billions of years. But the biggest mystery still remains. Where did it come from? Scientists have debated this question for years, and the answer may not be simple. Because the moon's water could have more than one origin. Let's explore the possibilities. Theory 1. Delivered by comets. Billions of years ago, the solar system was a violent place. Massive icy comets traveled through space like frozen bullets. When they collided with planets and moons, they exploded with unimaginable force. These comets are rich in water ice. If even a fraction of their water survived impact, it could have settled into shadowed craters near the poles. Over millions of years, repeated impacts may have slowly built up reserves of lunar ice. In this theory, the moon didn't create its water. It was given water, a cosmic delivery from the outer solar system. Theory 2. Water-rich asteroids. Not all impacts come from comets. Some asteroids, especially carbon-rich ones, contain water locked inside minerals. When these asteroids crash into the moon, heat releases water vapor. Some of that vapor may escape into space, but some of it could migrate across the surface until it finds a permanently shadowed crater. And once trapped in that freezing darkness, it stays. This process may have repeated countless times over billions of years, slowly, silently building lunar ice deposits. Theory 3. Created by the sun. This idea is perhaps the most surprising. The sun constantly emits a stream of charged particles known as the solar wind. Among these particles are protons, essentially hydrogen nuclei. When these hydrogen particles strike the moon's surface, they collide with oxygen atoms locked inside lunar rocks. Hydrogen plus oxygen equals water. Tiny amounts, molecule by molecule. It's not rain, it's not rivers, but it is chemistry happening in real time, powered by the sun itself. In this theory, the moon doesn't just receive water, it manufactures it. Theory 4. Born from within. Some lunar rock samples reanalyzed decades after the Apollo program revealed something unexpected. Traces of water locked inside volcanic glass. This suggests that deep inside the moon, there may have once been water. Billions of years ago, volcanic eruptions could have released water vapor from the lunar interior. Some of that vapor may have escaped, but some may have frozen at the poles. If this theory is correct, then some lunar water is not delivered, not created, but ancient, part of the moon since its earliest days. So which theory is correct? Comets, asteroids, solar wind chemistry, ancient lunar volcanoes? The truth may be all of them. The moon's water could be a mixture of cosmic gifts, solar reactions, and ancient internal processes. A layered history written in ice. And understanding that history doesn't just answer a scientific question. It tells us whether the moon can support the next giant leap for humanity. Because in the next chapter, we'll explore what form this water actually takes, and whether humans can truly use it. 5. What form is the water in? We've discovered that water exists on the moon. We've explored how it may have arrived, but now comes a critical question. What does this water actually look like? Is it flowing beneath the surface? Are there underground lakes? Could astronauts one day walk beside frozen lunar rivers? The answer is more subtle and more fascinating. Frozen in eternal darkness. The most significant discovery is water ice. Not liquid water, not snow falling from the sky, but solid ice, trapped inside the permanently shadowed craters near the moon's poles. These craters are so cold that ice can survive there for billions of years. The ice is not smooth or crystal clear like what we see on Earth. Instead, it is mixed with lunar dust and rocky debris, forming what scientists call dirty ice, buried within the soil, hidden beneath layers of regolith, but real and measurable. In some regions, scientists estimate that millions, possibly billions, of tons of ice may exist, molecules locked in soil. But that's not the only form. There's another type of lunar water, even more mysterious. Tiny water molecules and hydroxyl, OH particles, cling to the surface of lunar grains. These are not chunks of ice. They are microscopic traces bonded to minerals, created by solar wind interactions or delivered by impacts. During lunar day, some of these molecules may break apart. During lunar night, they can reform. It's almost like the moon breathes water, forming and losing it in a delicate chemical cycle, invisible to the human eye, but detectable by sensitive instruments. Ice below the surface. Recent studies suggest that some ice may be buried beneath the surface, protected from radiation and extreme temperatures. If so, it could be easier to access than scientists once believed. Instead of scraping tiny molecules from dust, future astronauts might mine frozen soil, extracting usable water directly from the ground. So the moon does not have oceans. It does not have rain. But it does have something incredibly valuable: frozen reserves of life's most essential ingredient. And that changes everything. Because in the next chapter, we explore why this discovery isn't just scientific. It's revolutionary. How lunar water could fuel rockets, sustain astronauts, and turn the moon into humanity's gateway to Mars. 6. Why lunar water changes everything. Water on the moon is not just a scientific discovery, it is a turning point. For decades, the biggest challenge of space exploration has been one simple problem. Everything must be carried from Earth: food, oxygen, fuel, water. Launching supplies into space is incredibly expensive. Every kilogram costs thousands of dollars to send beyond Earth's gravity. But what if we didn't have to carry everything? What if the moon could provide what we need? Water means life. First, water is essential for survival. Astronauts need it to drink, to grow food, to maintain hygiene. If future lunar bases can extract water from the surface, missions could last longer, maybe even permanently. The moon could become more than a destination. It could become home. Water means oxygen. Water is made of hydrogen and oxygen. Using electrolysis, scientists can split water into these two elements. Oxygen can be used for breathing inside habitats. No need to ship tanks of air from Earth. The moon could literally provide the air astronauts breathe. Water means rocket fuel. Here's where it becomes revolutionary. Hydrogen and oxygen are also powerful rocket fuels. If we can extract water and split it into hydrogen and oxygen, we can create fuel on the moon. Imagine spacecraft launching from the moon's lower gravity using fuel made from lunar ice. Instead of launching massive rockets from Earth, we could refuel in space. The moon becomes a cosmic gas station, a stepping stone to Mars, to asteroids, to the outer planets, a gateway to the solar system. Because the moon's gravity is only 1/6 of Earth's, launching from there requires far less energy. That means deeper space missions become cheaper and more achievable. With water as a local resource, the moon transforms into a scientific laboratory, a training ground for Mars missions, a fuel depot for interplanetary travel. The discovery of lunar water doesn't just change lunar science, it changes humanity's roadmap to the stars. For centuries, the moon was a symbol of mystery. Then it became a place we visited. Now, it may become the place that launches us into the future. But one final question remains. How close are we to actually using this water? In the next chapter, we explore the missions that are racing toward the moon. And what happens next? 7. The return to the moon. The discovery of water on the moon did more than surprise scientists. It reignited a global race. After decades of silence, humanity is preparing to return. Not just to visit, but to stay. And this time, we are going back with a purpose. NASA's bold new era. The United States has launched an ambitious plan known as the Artemis program. Named after the twin sister of Apollo in Greek mythology, Artemis represents a new chapter in lunar exploration. But this is not a repeat of the past. The goal is no longer flags and footprints. The goal is sustainability, permanent presence, long-term exploration near the moon's south pole, the very region where water ice is believed to be most abundant. Future astronauts will land closer to the shadowed craters than ever before. They will test new technologies, new habitats, and possibly new methods to extract water directly from the lunar soil. India's continued exploration. India has also played a crucial role in the discovery of lunar water. Following the groundbreaking findings of Chandrayaan-1, the country continued its exploration with newer missions aimed at studying the moon's south polar region in greater detail. Each mission adds more pieces to the puzzle, mapping ice deposits, studying temperature extremes, understanding how accessible this water truly is. A global effort. China, Europe, Japan, and private companies are all investing in lunar exploration. This is no longer a competition between superpowers. It is a shared step toward humanity's future in space. Robotic landers are being designed to drill into the surface. Rovers are being built to analyze ice-rich soil. Engineers are developing systems to purify and store lunar water. For the first time in history, the moon is not just an object in the sky. It is becoming infrastructure. The challenges ahead. But the mission is not easy. Extracting water in extreme cold is technologically complex. Operating in permanent darkness requires advanced power systems. Radiation levels are high. Dust is abrasive and dangerous to machinery. Every solution requires innovation. Every step demands courage. And yet, humanity has always been driven by impossible dreams. From crossing oceans, to walking on the moon, to exploring Mars. Water on the moon is not just frozen ice. It is frozen opportunity, a resource waiting to unlock a new era. And as rockets prepare to launch once again, one thing is certain. The story of lunar water is no longer about discovery. It is about destiny. 8. The moon's hidden promise. For centuries, we looked at the moon and saw a silent, lifeless world. A gray desert, a barren rock, a distant companion in the night sky. But science has a way of revealing hidden truths. Beneath layers of dust, inside craters untouched by sunlight, locked in eternal darkness. Water has been waiting. Not oceans, not rivers, but something just as powerful. A resource that could sustain life, fuel rockets, create oxygen, and transform the moon from a destination into a launching point. The discovery of lunar water has changed how we see our nearest neighbor. It is no longer just a symbol of mystery. It is a symbol of possibility. Perhaps comets delivered it. Perhaps asteroids left it behind. Perhaps the sun itself helped create it. Or perhaps the moon carried it within from the very beginning. Whatever its origin, one thing is clear. The moon is not as lifeless as we once believed. And as humanity prepares to return, armed with new technology, new ambition, and new dreams, we stand at the edge of another giant leap. The next footprints on the moon may not just be explorers. They may be builders, scientists, settlers, dreamers. And when future astronauts look across the frozen shadows of the lunar South Pole, they won't just see ice, they will see the future of humanity. Because the story of water on the moon is really the story of us, our curiosity, our persistence, our endless desire to explore the unknown. And this time, when we look up at the moon, we won't just see a light in the darkness. We'll see opportunity. So friends, this was today's amazing information. Hope you liked this video and learned something new. If you found the video interesting, don't forget to like, share, and subscribe. See you again in the next video with another new and surprising thing. Until then, stay happy, stay healthy, and stay tuned to learn. Jai Goga Sikatar Ma.